Headphones, please. I know, I can tell. Come on. Michael. Come on. Right ear and left ear, please, both. What's your name? You go. I gave you one yesterday. Anybody else? Alexis, come on. Headphones, please. Unplug.
All right, guys. The lesson is derived from the following standards. FIF4, for a function that models a relationship between two quantities, interpret key features of graphs and tables in terms of the quantities, and sketch graphs showing key features given a verbal description of the relationship. Also FBF4A, find inverse functions. Solve an equation of the form f of x equals c for a simple function f that has an inverse, and write an expression for the inverse. All right. Today's date is February 15th, young people, and you guys are about to learn how to find the inverse of a function or relation. And you're also about to learn how to determine whether two functions or relations are inverses of each other. Let's go ahead and commit these objectives to your notes, please. Savage, you're supposed to be writing this down, baby. Let's knock it out. Everybody should be writing their objectives. There's a whole pocket missing. All right, y'all ready to go? You? Okay. Okay. All right, so the vocabulary words that we may be pulling from, or will be pulling from today, is inverse relation and inverse function. Essentially, inverse. All right. Now, what is an inverse, young people? I can say it as plainly as this. It's when the domain and range switch places. Who remembers what the domain is a collection of? Anybody? What is the domain of a function? I don't. Domain and range. I'll give you a hint, X and Y. What is the domain? Domain is the collection of all X values. collection. Y'all need to write this down because by now we've been saying domain a lot. We've been using domain a lot. You all need to remember this, okay? The domain is the collection of all X values, okay? Or input values, if you will. The range is the collection of all Y values, okay? Now, very simply, young people, when you're finding the inverse of a relation or a function, all right? When you're finding the inverse of a relation or a function, very simply, what's happening is the domain and range are switching places. X and Y are switching places, okay? So look at the words. It says two relations are inverse relations if and only if, baby. Two relations are inverse relations if and only if whenever one relation contains the element AB, okay, starts off with AB, the other relation contains the element BA. What did A and B do? They switched places. A went where B was and B went where A was, right? Michael, you finna have a new seat, baby. You finna go. Who sits right there in front of you, baby? Who's that? Christian. Who sits in front of you, Jada?
Nobody.
Michael, that's your new seat, baby. Come on, sugar plum.
You're right behind me.
Plum sugar. Lump sugar, baby. In front of Jada.
Right in front of you.
Get your stuff. Grab all of your items. You put your head down one too many times, sugar baby.
I'm still writing.
You better stop playing with me. Is that your phone? You gonna leave it over there?
Yeah.
All right. All right. And you can see the board real good. So essentially, young people, okay, A and B have switched places, correct? All right. Look at the example. It says A and B are inverse relations. Why? Well, look at the point. Look at the 0.15. Okay. In the set A. Okay. In set A, we have the 0.15. But look at the set B. 1.5 became what? 5.1, right? In set A, we have the 0.26. We have the order pair 2,6. But in collection B or set B, 2,6 becomes what? 6.2. Okay. And then finally, 3.7 became what? 7.3. X and Y switch places, Alexis. Put your phone away. Make sense? Okay. X and Y switch places. Move forward. So look at this situation, young people. Real quick, we're not going to belabor the point, but the ordered pairs of the relation, of the following relation, 1, 3, 6, 3, 6, 0, 1, 0, are the coordinates of the vertices of a rectangle. Find the inverse of this relation. We won't be graphing. Find the inverse. Well, young people, if I began with 1, 3 in my new set, in my inverse set, okay, 1, 3 is going to become what? 3, 1. Okay. And 6, 3 is going to become, Miracle's the only one that knows how to do this. 6, 0 becomes, and 1, 0 becomes, yes, X and Y switch places. That's it. Okay. Now, is it going to become more intricate? Yes. But the hallmark is the same. X and Y switch places, period. Okay. May I proceed? Okay. May I proceed? Let me know, okay? All right, you good? All right. All right, so very quickly on your own, the ordered pairs of the relation -3, 4, -1, 5, 2, 3, 1, 1, and -2, 1 are the coordinates of the vertices of a pentagon. What is the inverse of this relation? What is the inverse? Gotta be D, because doggone it, B and C start off with the same doggone point, don't they? Gotta be D. Okay? All right, any questions or concerns about this? Pretty simple, right? With the points. Okay. All right. Now let's move it on to functions. Okay. We talked about relations. Now let's talk about functions. Okay. Now in words, here are the properties of inverses. If F and F inverse, that's how you say that. If F and F inverse are inverses, okay, then F of A equals B. If and only if F inverse of B equals A. Essentially, young people, the A and the B have done what? Switch places. The X and the Y have switched places. Don't get caught up in the weird jargon and the weird symbols. All that's happening is A and B are switching places. That's it. All right. And again, if F and F inverse are truly inverses of each other, okay, if F and F inverse are inverses, a little redundant in the wording, but whatever, okay, then F of A equals B, if and only if F inverse of B equals A. Okay, so look at the example. It says let F of X equals X minus 4 and represent its inverse as F inverse of X equals X plus 4. So we have the function F and its inverse. Now, they want me to find F of 6. Okay, cool. When I plug in F of 6, okay, here's my function, F of X equals X minus 4. When I plug in 6, I get 6 minus 4 or 2. Okay, cool. If F of 6 equals 2, that means if they are inverses, F inverse of 2 would have to be equal to what, y'all? Hello? Would have to be equal to 6, switching places. So let's see if that's true. Evaluate F inverse of 2. Well, here we are. F inverse of X equals X plus 4. We're plugging in 2. You don't have to write this down. Just walk with me, okay? 2 plus 4 equals 6. Are these, in fact, inverses of each other? Yes, because F of X equals 2. I'm sorry, F of 6 equals 2, and F inverse of 2 equals 6. Okay? Let's make it real. Just want you to understand how the rules work, okay? Let me show y'all something. We started off with F of X equals X minus 4, right? How did they know that they were inverses? F of X equals X minus 4. Let's start off with a very simple function. Hold on. Start off with a very simple function. Young people, when you are finding, now they gave us the inverse in the previous example, right? I'm about to show you how to find the inverse no matter what, right? So right now, this function is written in function notation. F of X equals X minus 4. But I'm going to replace the F of X with Y, okay? Y equals X minus 4, same thing. The function evaluated at X is the same thing as what is the value of Y when X is whatever. Same difference, same situation, okay? Now, what have I been saying the whole time about how to find the inverse? What's switching places? X and Y, young people. When you're trying to determine the inverse of a function, X and Y switch places. So right now I have Y equals X minus 4, right? Now, to find my inverse, I'm going to have X equals Y minus 4. X and Y switch places. Now, once X and Y have switched places, then just solve for Y. Then just solve for Y to find your final inverse. Get Y by itself. In this case, how do I get Y by itself? I'm going to add 4 to both sides. Okay, cool. And I get that y equals x plus 4. Okay, cool. So young people, we started off with f of x being equal to x minus 4, didn't we? And we just found that f inverse of x is equal to what? X plus 4. It's a very simple example. Will it get more involved? You bet your bottom dollar. But let's just start off with something simple, shall we? Did that process make sense? This is what we're about to be doing all day. X and Y switch places, and then solve for Y. This is Kimberly Bunting. Y'all, this is Frank on a recorded line calling about Medicare rewards. I'm gonna talk to Frank later. All right. Anyway, I know I'm old, but I ain't that old, dang. Right, your car warranty about to expire. Oh my gosh, they probably call some of y'all phones, don't they? Talking about your warranty, like what car? I don't have a car. Anyway, all right. So how we feel about the process? We're about to do another one. Don't worry. It's the first one. Just remember, X and Y are gonna do what? Switch places, and then we're gonna solve for Y again. Okay? You ready to move on? All right. Oh, I'm sorry. I say I'm sorry. You good? Anybody else? Anybody else? All right, let's go. All right, sugar babies. Here's another situation. They want us to find the inverse of f of x equals -1/2 x plus 1. Let's start by writing the function down. Okay, I'm change my color. I don't like that. Let's start by writing the function down. F of x, this is what you should be doing. F of x equals -1/2 x plus 1. Just go on and write it down. Just write it down. Just write it down. Okay, we got it down? Almost? If you don't put that doggone phone down, Alexis, is this why you behind? You distracted on that cell phone. Say no?
Like in this method on that?
No, I'm talking about on the notes. Get out that phone. I believe you. I wish it was 1988 so bad. Ain't nobody have a cell phone. Nobody. Nobody. You know what kids did when they were off task in class? They drew pictures or they read a book. During, like, that was considered off task behavior. Well, now you're being deviant. Stop being bad. But anyway, y'all ready? So on the last problem, what is the first thing I did to this f of x? Made it a y. Let's do that. I'm gonna change it from function notation to just regular x and y. Okay? Y equals -1/2 x plus 1. Okay? Just in a regular equation format, no function notation. Okay? All right, cool. What's gonna happen next? What do we do next? What's the hallmark of inverses? What have we been doing the whole time? I see Mary is doing this. So what am I, she said switch. Switch what? X and Y, switch X and Y. So let's do it. I'm gonna scooch over here like this. And X and Y are switching places. So I'm gonna have X equals -1/2 Y plus 1. Okay? Michael, I need you to stay with me, baby. You should be writing this down. You raising your hand?
No.
Okay. X and Y switch places. Now, after X and Y switch places, then what do we do? Solve for Y. Solve for Y. Get Y by itself. What's the first step? What do I have to do? Be careful, Savage. You see that plus 1? Gonna subtract 1. Okay? Subtract 1 from both sides. So you'll end up with negative 1/2 Y equals X minus 1. Okay? I love a little space because it's about to go down. Something's about to happen. Because I got to get rid of that fraction, right? Now we could divide everything by the fraction negative 1/2. Okay? But that'll make things a little messy. And I know how much you guys love fractions, right? You love them? I know y'all love them. I get it. So let's do this. You see the negative 1/2 Y? Remember this, young people. If you multiply by the reciprocal of a fraction, okay? If you multiply by the reciprocal of a fraction, that will turn it into 1. Okay? That'll turn it into 1. All right? And just like I multiplied by negative 2 over 1, which is just what? What's negative 2 over 1 the same thing as? Just negative 2. Negative 2 over 1 is just negative 2, right? I got to multiply it over here as well. Notice that I've thrown these parentheses around because everything has to be multiplied by negative 2. Okay? Now over on the left, negative times a negative is a positive. And these 2's cancel out and these 1's cancel out. Y'all with me? Okay? And then finally, Y is equal to what? Let's distribute the negative 2, shall we? Negative 2 times X will give me negative 2X. Negative 2 times negative 1 will give me a positive 2. Bless you. So young people, to write my answer out, okay, if f of X equals negative 1/2 X plus 1, then f inverse of X, okay, see how I say that? F inverse of X is equal to negative 2X plus 2. How are we feeling? Questions? How we feeling? Y'all okay? Is this making sense to y'all? Okay. May I proceed? Okay. Yep.
Why do we have to have f to the negative 1?
That's the inverse notation. This is the original function, f of X equals 1/2 X plus 1.
Oh, yeah.
And then we just went through the process
I got it.
and found the inverse. May I proceed? All right. All right, so let's talk about this one. Put a little bit more stank on it, right? Find the inverse of f of X equals x cubed minus 4. This is gonna be so much fun. Yay. Ugh. You don't cover your mouth up? Harking all of that. You better have COVID either. Don't make me come over there. Up in here breathing out like that. May I proceed? Can I write it down with y'all? So I have f of x equals x cubed minus 4. Now, some of y'all done already did what? What's my first step? Change the f of x to what? Change it to y. Boom. Y equals x cubed minus 4. All right. Now, what do I do? What did I do in the last problem at this point? Switch it on up. All right. So here we go. X equals y cubed minus 4. Do you see? X and y have switched places. You don't change nothing else. Do y'all hear me? You see how that 3 is, the 3 is still an exponent? It did not move, did it? Nothing moved, did it? All right. I had a student that felt like it needed to move with the x. Oh, no, no, no. Only thing that's moving is literally the x and the y. Clear? May I proceed? Now what do I do? Yeah, inverse operations. You better use your vocabulary, little girl. Shoot, y'all Miracle over here using that vocabulary. She said use your inverse operations. Yup. So that means I see a -4. What do? Yeah, I'm going to add 4 to both sides of my equal sign. Okay. So I end up with y cubed being equal to x plus 4. Alexis, don't make me come over there. Put it in your backpack. Alexis, put it in your backpack. That's not your backpack. That's not your backpack. That's not your backpack. Thank you, sugar baby. All right. So now I've almost gotten y by itself. Y'all see that cubed? Who remembers how to get rid of a cubed? Square root or cube root? Okay, you were right there. Good job. So I'm going to take the cubed root of both sides. Okay, cubed root of both sides. You see? So this cubed root cancels out with this cube, right? Cancel each other right on out. And I get my final answer as y equals the cubed root of x plus 4. So if I wanted to write it out, if f of x equals x cubed minus 4, then f inverse of x is the cubed root of x plus 4. How we feeling? Are we okay? May I proceed? Does anyone object to me proceeding? Okay, all right. All right, so now let's switch gears. So the second, let me go back to the objectives. Do you feel that we have fulfilled the first objective, where you have learned how to find the inverse of a function or a relation? Did we do that? All right, cool. Now we're about to move on to the second one. I'm about to teach you how to determine whether two functions are or relations are inverses of each other. So let's go. How do you know if two functions are inverses of each other? I don't know. I do know. I'm just kidding. Remember how we learned how to find how we compose functions yesterday, Jamari? Okay. Which essentially meant that we took one function and set it inside of another, right? That's really what happened. Well, in order to determine if say I said I give you function f and function g, are they inverses of each other? You would say, I don't know. I'm gonna do that. I'm about to tell you. Babies, very simply. I'm going to read the words first, and then I'm going to show you symbols, and we're going to do some examples. So the words indicate, or the text indicates, that two functions f and g are inverse functions if and only if both of their compositions are the identity function. What is the identity function? Well, it's y equals x. Okay? Y equals x is the identity function. Look at the symbols. The symbols is really what I want you to write down. The symbols is really what I want you to write down. Okay? Here are the symbols, which is still a sentence. F of x and g of x are inverses if and only if f of g of x equals x and g of f of x equals x. So essentially, f of g of x is equal to x and g of f of x. Oops. G of f of x equals x. They both have to be equal to x. Oh, Lord have mercy. Y'all want to try one? Y'all got it? You don't want to try one and you don't have it. I'm confused. Whatever. All right, here we go, y'all. So here we go. Determine whether f of x equals 3 over 4x minus 6 and g of x equals 4 over 3x plus 8 are inverse functions. Well, how are we going to figure that out? I don't know. Remember, I'm going to have a f of g of x side, right? And I'm going to have a g of f of x side. Both of these situations ultimately have to both be equal to what value? Okay. What do they both have to be equal to? Have to both be equal to x. Okay? So let's find f of g of x. Let's find f of g of x. Remember, yesterday I taught you just start off by writing down the function. F of x equals 3 over 4x minus 6. Okay? But I'm not finding f of x, I'm finding f of g of x, right? So f of g of x, yes, I'm going through all the steps, will be 3 over 4 times g of x minus 6, right? Do we know what g of x is equal to? Okay, I'll wait, let y'all catch up with me. Do we know what g of x is equal to? So everywhere I see a g of x, I'm going to replace it with 4 over 3x plus 8, right? And then I bring down that minus 6 out here, right? Yep. Y'all got it? So now, young people, don't just sit there and see a 3/4 on the outside of a set of parentheses. What do you think you should do with this 3/4? Simplify it how? When you have a fraction or any number on the outside of a set of parentheses, what do you do with it? Say, yeah, distribute. So I got to say 3/4 times 4/3. Young people, if you don't know what that is, you should be using your calculator right now. 3/4 times 4/3. Go. Type it in. Use your fraction key. 3/4 times 4/3. What does that give you? Marion says it's 1. Is she right? Is she? Okay. So that'll be 1x, right? And then I got to say 3/4. Okay, I said 3/4 times this one. Now I got to say 3/4 times this one. What's 3/4 times 8? Okay. Plus 6. Then I bring down the minus 6, right? Well, tell me, baby, what is 6 minus 6? 0. And 1x, do I need that 1 there? Nah. So is f of g of x equal to x? Hello? Yeah. It's equal to x. We just simplified it. So now we got to shimmy over here and find g of f of x. Let's go. We start out by writing down the function g of x. G of x equals 4/3x plus 8. But I'm not finding g of x. I'm finding g of f of x. You better not. All right. Everywhere I see an x, I'm replacing it with f of x. Do we know what f of x is equal to? Thank you. 3/4x minus 6. And then I got the plus 8 out here, right? Let me give y'all a minute to catch up. If you know what to do next, by all means, don't wait on me. Tiffany over there, I see her. She over there calculating. I see her too. I ain't mad either. I am not mad. So, are we ready to distribute the 4/3? What is 4/3 times 3/4? Huh? It's 1. So this is going to be, bless you, 1x. What is 4/3 times -6? -8. Then I bring down my plus 8, right? Well, what's -8 plus 8, y'all? 0. And then this 1x, we don't need that 1 on there, do we? So did we just show that g of f of x is equal to x? All right, so f of g of x equals x. G of f of x equals x. So what may I conclude about f of x and g of x? They're inverse functions. Come through, Marion. They're inverses of each other. How do we feel? Make sense? You will have to show this process on the test. You will have to show this process on the test. Questions, concerns, issues? Yes. Inside the parentheses, every situation will be different, but you just do what the numbers tell you to do. So if you have a number on the outside of the parentheses, yeah, you would have to distribute in this case. Okay? But I mean, I'll never say it'll always be this way because it won't. Yes. You would say that they're not inverses of each other. If they end up being anything else other than x, they're not inverses of each other. Okay? Anybody else? All right. Do this one on your own. Do this one on your own. Determine whether f of x equals 3x plus 1 and g of x equals x minus 1/3 are inverse functions. Are they inverse functions? What do you have to do? What do you have to do? Kendall, you be working this out, baby girl. See what y'all working with over here. Uh-huh. If your pencil ain't in your hand, you better have answer your paper, man. I'm coming straight to you. Yeah, you home skillet. I'm about to sort your bread. That's what I wrote. I'm trying to help you out. You're not even taking the help.
I am.
Come on. What you doing? Yeah. I want you to do this like the previous example. I'm supposed to be doing it like this one. After you didn't do it right. And you need to organize it up to what it was. Very good. Keep going. There you go. Right here. There was something else coming up. It was cancel out. What's 3 divided by 3? That's not 3 times 2. Okay? What you got? Don't cover it up on me. Come on, man. At least write down what lesson. Look. I'm trying to help you here. Come on. Help me to help you. All right, so when these 3's cancel out, there's no more 3. Erase that. Okay, they cancel out. Okay.
Thank you.
Yes. You see? Yes. Why is it 5? What is that? Make it look like a 3. All right. And so, come on, what is g of x equal to? And stop calling me bruh.
I didn't say nothing.
It's called, I thought you called me bruh.
Right now?
Yeah.
I didn't say nothing.
My bad, no. I'm here anything. You can't call junk after I apologize. Dang. What is g of x equal to? Replace it. What is g of x equal to? Replace it. What is g of x equal to? Plug it in. Oh, okay. Yeah, keep going. That's good. That's good. What do you say? What happens to these 3's? Mm-hmm. Why is there an X right there? Should that be there? I don't think it should. Very good. Now, what happens to these 3's? Y'all, I think some of the way that some of y'all are writing this You're confusing yourself.
What happens to these threes?
You're confusing yourself.
I'll touch this.
Ma'am, what is G of X equal to? Almost. What is the little things cancel out? Right on the X. Right to the X. Same thing here. Redo it, finish it, redo it, fix it. You were so close, girl. So close, my goodness. All right, let's talk about it. This is almost perfect. You did the same thing Tiffany did. What happened to your X, man? That would be in front. In front. Your pick was almost perfect. All right, y'all, let's talk about it. Stop huffing your breath in here. Check your neck if you're sitting in front of him. All right. All right. Many of you all were able to get to this point where you would replace g of x with its equivalent, which is x minus 1 over 3, okay? Some of y'all were writing your 3's so big that it's not obvious what you should do with it. Some of y'all were writing your 3's like this. And it looks like you should multiply the 3's together. That is so wrong, okay? Don't do that. Don't do that, okay? Write it like that. Then I have the plus 1 out here. Now, at this point, you should clearly be able to see that these 3's do what? They cancel out, right? Okay, maybe I should do it in a different color. And so now I'm left with x, okay? X minus 1 plus 1. Some of y'all left the x off. Some of y'all left the x off for some reason. Don't do that. Okay, don't do that. So now negative 1 plus 1 would give you what? 0. Cancels out, okay? Equals to x. All right, so now let's shimmy over here to this side and find g of f. Come on, you guys have to do this on your own. And I'm gonna do the same thing like I did before. I'm gonna start you off, but you've got to, come on. If you just sit here and just copy down what I write down, you're not learning anything. Start off by writing the function g of x equals x minus 1 over 3. Then I have g, let me put a little bit more room in between here. G of x equals x minus 1 over 3. Now I have g of f of x equals f of x, minus 1 all over 3. Okay, do you see? See if y'all can take it the rest of the way. Can you take it the rest of the way? Is f of x equal to anything? Is f of x equal to anything? Using all of this. That's it. Okay. Look, It's not just 3x, it's 3x plus 1. You don't really talking to him. You sit, baby. You sit for real. And you out here yawning all hard and stuff. You sit for real. Okay, I want you. Okay. So that would be 3x plus 1 minus 1. Okay? You see what I'm saying?
Yeah.
Don't stop, pick your pencil up, finish writing it down. 3x plus 1 minus 1 up top. Take your items with you just in case, okay? Here you go. The Delta math assignment might make you feel better. All right. How we doing, folks? Let me see if I can try to write on this board. Look up for me, y'all. Pray for me. Yeah, bad experience. Yeah. I'm not gonna do it. Let me try. I'll try. Ah! What happened to the rest of it?
3x plus 1.
I don't like this. So ugly.
Yep.
Nope. Let me get back over here and mind my business. For some reason, it drags. All right, y'all. The right's thinner, though. All right. So you should have replaced f of x with what? What is f of x equal to, y'all? Uh-huh. So I have 3x plus 1. I'm just going to, because I tell y'all all the time, keep it in parentheses, because you never know what's going to happen. Let's just keep it with the parentheses, okay, Alexis? And that's going to be all over 3. Now look what's happening in the numerator. Look at your numerator. Look at it very carefully. Put that calculator down. You don't need it. You don't need it. Because I got a positive 1 right here, right? Nothing's happening to the values inside the parentheses. Nothing's happening at all. So I have a positive 1 here and a negative 1 here. Tell me, babies, what is 1 minus 1? It's 0, right? So this is going to become 3x over 3, does it not? Does it not? What happens to those 3's? They cancel out. So g of f of x equals x, right? Because my 3's cancel out. And back over here, I didn't write it, but f of g of x also equaled x. So what may I conclude about functions f and g? They're inverses. Does the process make sense now? You feel a little bit better? Hello? We okay? Valeria, you feel better? It's okay? Larissa, were you able to get this one? Okay. You started off real strong on the last situation, so. All right. My apologies. You got it? Michael, let me know when you're done, okay? All right. So to answer the question, babies, are these functions inverses of each other? Yes, they are inverses since both compositions equal x. Equal x. Okay? Questions, concerns, issues? All right. Let's shimmy on over to Delta Math. Show me what you're working with. You understand how to do this? Prove it. You understand how to do this? Prove it. Michael, go ahead and get that bottle and throw it away from Miss Sugar Baby. Thank you. Yeah, take a pass, baby. Study having.
So, that means, you, yesterday you did all your Delta Math, right?
Yeah.
You're the only one that did all of it. Okay. Right. Okay, so then,